Hi, I'm Alan Ross. I'm the managing editor of APC Technologies. We are at the IEEE PES Grid Edge Conference, one of the sponsors of these interviews. And our other sponsors are Dynamic Ratings and H2 Scan. Enjoy these interviews. My next guest, Arman. Arman and I have done this before.
Yeah, it's a pleasure to reconnect, I would say.
To reconnect it. Tell me a little bit about you and Edge-Tune Power, because other people that have not seen this interview don't know why I'm interviewing.
Sure, definitely. My name is Arman Ghasaei. I'm the founder and CEO of Edge-Tune Power. I incorporated the company in 2021 after I finished my PhD at University of Toronto. And since then, we have 3 projects with utilities in Canada. And our mission is to push the grid limits further for decarbonization, digitalization, and decentralization.
To push grid limits for, I love that. Okay, because now let's get into it. What's your definition of the grid edge?
Great point. I believe people have different definitions, but the way I see it, you have a edge technology, or you're addressing edge operation of the grid if you're looking at real-time information that are coming from the grid at the edge, and you're not relying on historical behavior of the grid. Okay. And as we see more interconnection of renewable resources and battery energy storage systems, the grid is becoming more unpredictable, and that's why it's important to look at the real-time and at the edge operation of the grid rather than historical.
And then so edge tune is a great, you're tuning at the edge, but you just mentioned because of the instability that is introduced to the grid at the edge from wind, solar, battery storage, electrification. Let's talk about the impact of electrification on the grid and on the grid edge.
Believe it or not, West Vancouver in Canada is a wealthy community. There are many Tesla drivers out there, but as I'm speaking right now, we have just one publicly available fast EV charger in West Vancouver.
Just one?
Just one. We have 270 gas stations over there. Issue is not the supply, for sure. We have ABB, Schneider, Siemens, Tesla. Issue, and they say that battery storage technology is supposed to enhance the grid for interconnection of EV charging stations. And we are referring to fast EV charging stations. But battery is a dummy component. It doesn't know what to do. And issue is the infrastructure, which is the aged legacy electric grid. Right. So my question is, if the existing DERMS and ADMS, if they would be good enough, why we are seeing just one publicly available fast EV charger in West Vancouver? So if you want to really realize electrification of transportation, you have to make sure the grid has the hosting capacity for this electrification. And storage is the key and I would say, main component to realize the electrification, but again, you need a fast management system on top of it. And that's where we come into the picture with the edge technology or edge management system.
Okay, so why do you think West Vancouver has only one fast charging station? What is the limit? Is it brain power, people not knowing? Because it seems to me that the demand is growing and going to grow a lot because Canada is pushing electrification in transportation. US, obviously, the whole West Coast, Washington, Oregon, California are pushing it. Why do you think we're not there?
So first of all, when I look at the online websites like Charge Hub, where they are showing the real-time location of the EV chargers, the pictures are self-explanatory. Like you see like one EV charger in West Vancouver. For example, in North Vancouver, there are 5 EV chargers, and BC Hydro, which is the utility in Vancouver, is pretty happy about it, but they are super condensed and centralized because they are connected to the point where the grid is strong. So these are the proof that electrification is not really happening. Like we are seeing limited number of EV chargers. So again, the issue is the infrastructure or the grid, and utilities are reluctant to interconnect more EV chargers because to them these are alienated sources of consumption or generation. So they're looking for solutions where those solutions provide like a relief for them that there won't be any negative impact from interconnection of these intermittent resources. And by intermittent resource, I just not referring to renewable. EV charging station is an intermittent resource. It can generate or consume.
So when you move away from EV charging stations and you think about charging at home, okay, all of the people now they go residential, and at 5 o'clock when everybody starts to cook and air conditioning when it's there, or heat or whatever goes up, now they're charging their vehicles. What is the complexity that adds to the system, to the grid?
Sure. Just a quick point before that, the EV charging stations, I'm not saying station, the EV charging ports which are available at residential scale, those are slow charging stations, so they are not problematic as much as fast EV charging stations are. But even at that stage, they are changing the load profile of the grid. Because again, at the moment, management systems are looking at historical data, and historical data don't reflect impact of EV charging stations. Sorry, I again say stations, but like even EV chargers at the residential level.
So obviously you started the company and you had an idea of what it is that you would bring, and you had to reflect on the environment that you would bring the company into, right? What is the value proposition, the solution that you think Edge-Tune Power brings to the grid edge?
Sure. So everybody believes that the approach to reach a decarbonized grid and electrification of mining or transportation is not interconnection of more transmission lines, because they are super costly and super timely. Per every mile, a transmission line costs about $400,000 on average for utilities. And everybody believes that the alternative are storage systems. But we all know that storage systems are running in milliseconds. They're pretty fast. So if you put a brain on top of it, which is running in minutes or hours, you are underutilizing the battery energy storage system. And that's why you cannot enhance the capability of the grid for full electrification of like transportation or full decarbonization. Coming to our technology, we have I said patent pending in RE Plus a couple of months ago, but I'm happy to say patented right now.
Right? Okay, good.
So,
congratulations on that, by the way.
Thank you so much. So we have a patented grid management system right now, which, including communication latency, can make actions and command the battery to kick in millisecond level. And I don't want to get too technical, but if you're not running in that time frame, we all know that parallel to control, we have protection systems. So the protection system will already trip and will shut off the grid. So which also brings us to the concept of resiliency of the grid. So our patented grid management system is fast enough to fully utilize the storage system for full decarbonization of the grid and full electrification of other sectors using storage system to its maximum capacity.
So as storage systems grow, which they have to grow, I mean, we had another interviewer and we were talking about utility storage, talking about data center storage, because data centers are now very heavily involved, telecom storage systems. So there's a lot of different approaches to storage, but the one problem that person talked about was energy management systems that aren't keeping up. What you're saying is your Edge-Tune Power energy management system keeps up. It's the next generation.
We call it power management system.
Okay.
Because energy in short time frame is translated as power, and exactly. We are addressing that shortcoming in the market, which is a fast brain, or let's say fast power management system for the storage system to provide its full capability for addressing the concerns, which can be like resiliency of operation of a data center. It can be enhancing a rural feeder for EV charging station adoption. So yeah.
So all of this harmonics and all of the wind, solar, storage, and electrification have created a power quality issue that. Now, how does that affect, or how are you affected or how do you positively affect power quality?
Sure, we are happy that these issues are rising.
Well, don't let your customers hear that you're happy about a problem.
Yeah, but I mean, like, because of those issues, we have a value proposition. So harmonic distortion, which is related to power quality issue, is like one of the concerns of utilities. And not only addressing it, but monitoring these power quality issues is a big challenge. So it needs like a clear understanding of those new phenomena that are represented with distributed resources. So our technology can fully compensate power quality issues like harmonic distortion, voltage sag, voltage fluctuations, again, thanks to its speed.
Okay. So when you say they can handle it, is it a timing issue, or is it just a technology issue? How is it? I know you don't want to get too technical, but how is it handling it?
So our technology,
Yeah.
you mean? So at the very back stage of our technology, we have a decision-making algorithm. It's a proactive decision-making algorithm. By proactive, I mean we can envision large number of accidental events that can happen in the grid, like sudden opening of a circuit breaker, or like, let's say you install an EV charger, but you didn't predict that there is going to be some voltage fluctuation issues with the distribution lines. We don't need to look at historical behavior of the grid. We can detect these events and large number of these events in a real time and in a very fast manner, make a decision, send that decision to the battery to take care of these situations in a very fast manner, and fast enough where protection doesn't kick in.
Trick, yeah.
And trip.
Okay, that's excellent. Use cases. Don't mention the customer, but where your technology is actually been employed, where are you with that? Do you have some use cases that you can
Sure.
wow us with?
Sure, I'm not gonna, like there are some NDAs out there, but it's okay if I say we have a project with Hydro-Quebec right now. It's a pilot testing, and there is a remote community which should act as a microgrid during unintentional and accidental islanding scenarios. And we are working with them to commercialize our fast grid management system. So when that remote community loses its connection from the provincial grid, it's not going to be like a restoration process. It's going to be a seamless islanding process. They won't notice anything. And at the same time, in Canada, and I'm pretty sure it's the same scenario in the States, there are many remote communities who are getting energy from diesel-based fossil fuels and diesel-based resources. Diesel becomes more expensive than gas these days. Security of supplying diesel is an issue. So not only they get energy from exorbitant electricity, but there's no economy development in those areas because electricity is expensive. So if you want to replace diesel with intermittent sources of generation and batteries, again, you need a fast management system on top of it. That is one use case, and the other one, which is under development right now, is proliferation of fast EV chargers in downtown areas of Vancouver, as well as generally intercity areas.
Okay. Any work going on in Toronto, my home city?
Yep, and I'm prematurely aging. We just got a project in Toronto. I forgot to mention.
Good.
Yeah, so we just got like another project a couple of months ago with a local distribution company in Toronto, in London actually, in London, right. Ontario.
Close enough.
Yeah, and we are working with the EPC company, SunGrid, for that project, and they're supposed to provide islanding capability for 6 residential buildings. So this is more of a residential scale project, and the remote community is also residential scale, so it's behind the meter operation. But the one that I mentioned in BC is more of a utility scale project because the battery is going to be owned by the utility.
Okay, all right, excellent. You've come a long way since RE+, and that's only been in September. So I'm going to be anxious to see, we'll be doing this again at RE+ in September. this year in Las Vegas, I think it is.
Yeah, I believe we are going to be there. Like my CEO is taking care of that. I'm
Okay.
not sure like how
Well,
it's
when
going.
he comes, I want an update. Even if we don't do an interview, I want an update.
Yeah, and I hope to pass new developments.
Okay, excellent. That's good.
Thank you
Arman,
so much.
Thank you
It was
so
a
much. for
pleasure.
joining.
Yeah, thank you so much.